if you want
Now
to
they're down in
come
the
over
Fulton
here.
area, which is their signal is. Not
Like it's 10, and there it is, 10.34 megahertz.
Yeah.
So you just change it to whatever you want. 19. Let me delete it. Where's delete? And that, now it would be on 19 megahertz, but and just recompile it. But sorry, Jim.
Something's going on.
Oh, you think it's that ground? Huh?
It's right in here.
Ah. Hold on.
If I let go, it craps out.
Oh, it's the ground lead. Do you have another ground lead? We can bring
It's
it.
the only ground
Wow.
I have.
Don't let anybody breathe.
Nobody.
Now change the frequency.
Okay.
Give them a little more
Yeah,
amplitude.
go down in frequency.
Okay, you want to go to what? 1 megahertz?
Yeah.
Oh, I'd like to get that on the picture too. Yeah, let me get out of your way.
You know, now is the time to hook up the counter to the scope.
So Jim, what is the application here? What is the...
You can use it for an IF, for the DDS,
You can
or a
make a video
SDR.
a transmitter.
Yeah, make your own little transmitter, digitally controlled. I'm working on an SDR rig using these.
You can
You can set the IF frequency, for example,
you can make a
430 megahertz or whatever it is.
an SWR meter for your like an antenna analyzer.
And notice it's continuously variable from pretty much close to DC all the way up to 40 megahertz.
With a very clean
And
signal.
if you use that for an IF, is that the only application? You'd have to have another one for another...
Yeah, but look at the thing, they cost $2 and they're this
I
big.
know.
You throw a couple of those in there and you're done.
Yeah.
You've got all your oscillators and they're all digitally controlled.
Yeah.
And a little microcontroller, you can hook it up to your laptop or whatever. I'm building interfaces with LCD displays, like that one on his thing over there.
And you don't need the Arduino board. You can use the chip all by itself.
I've taken the chips that come on the board, programmed them.
So, but this is the reason for this launch chip is because with the experimental board, you want to have a lot of features, like 16 analog signals in and
Oh,
out.
the Bear chip has those. The difference is this thing's got a USB interface. So you can download software and
For experimental purposes, then you can use the same one for many, many different applications. And then when you find out when you really want
It's got two different programs there. One is with the Morse code beacon, and the other one was this. Three different programs. Same hardware board.
Yeah.
Okay, now what we're doing, we're measuring the frequency in the output of the
What is it?
output of the scope, I think.
Where are you plugged in?
In the back of the scope.
I've got a couple, and I discovered that
The output of the vertical amplifier in the scope.
this metal can is, I think, 125 megahertz.
Yeah.
They're off a little bit, from one board to the next. So you have to figure out each board.
Doesn't seem to be
It's like it's jumping around.
What was I didn't compile it.
What was the frequency, Jim?
It was 10. Now it's should be 1 coming up.
Oh, there it is. Okay. There it is.
The amplitude changes too.
Yeah, it does. That's
Yeah.
interesting.
Yeah,
Yeah.
I'm surprised me. Hey, Jim, if it's okay if I tell them what I did with a pot?
Sure.
Okay, what I wanted to do
That's
was,
a nice clean
instead of having to recompile it every time for a fixed frequency, I wanted to have a continuously variable. So these little chips have got, I think, 6 channels of analog, 1024 bit analog. The little Arduino chip has 6 analog channels, each of 1024 bit resolution, right? So I hooked up a voltage divider, a pot as a voltage divider between the supply rails, with 0 to 5 volts, and I read it in, and then mapped it to a number between, say, DC and 20 megahertz, and then go like this. So I got a little pot on my, on my,
Yeah?
going, whoop, whoop. And then I put it in the audio range. I had it going into one of these things here.
Okay.
Yeah, it's pretty cool.
You listen to it.
Actually, I can show that to you, didn't I?
Yeah.
Yeah.
Yeah, amazing. So,
So that's is that reading 1 megahertz?
no, the output, I don't know what's, this used to work perfectly, but I don't know why it's on the back of the scope, but it's not working that way now.
So this is 36 kilohertz.
Maybe, how to say, maybe it's whatever the gain setting is. Maybe you don't have enough gain.
Yeah, I cranked that up. It's still clean.
It's very clean. You can
Yeah.
just tell nothing's moving at all.
Yeah.
The frequency or amplitude. Excellent. Dave, what have you got over here?
It's a second gen digital synthesizer also.
Oh.
Basically the same thing with a bigger board.
Yeah.
Oh, okay.
Yeah. And a 12-volt supply that's bigger than the whole circuit.
Yeah.
But this has got all the little buttons for its. You can program it with all the buttons.
I think you haven't got those where yet.
This is not the same board that he has.
No, this is different. This was.
Those boards, remember that crimper?
This has like a digital readout on the front, so it tells you what frequency you're on.
I don't think I'm going to be able
I
to
got
get
it
it
to
done
use
in
it for a
time to get
DFO.
back to you tonight.
Pretty stable.
And you know I'm going away
I
on
think it's-
Saturday. We'll be back.
There's a crystal reference in there.
We don't need to between now
And
and then.
they're not. It's not precise, but you can calibrate. You can calibrate it against.
Small supply here. I could get this running.
Yeah.
But you know,
But there's nothing on the screen right now.
Oh, there should be.
Yes, I know. I
Oh.
have an old lens from a slide projector. I need to take a look.
This
I
isn't
can't
going
read the part numbers.
No, it's this.
So to do that in the wiring, I always do the wiring one. I think you got some new ones. New jumpers, female.
yeah, well, they stick pins in
Blake.
Oh, I see. Yeah. I might give you a bundle of these guys. That's interesting. Did you make these up?
Yeah.
Little intermits, maybe.
That's the board's thing.
Yeah. I got all kinds of crap.
Yeah, when I saw that, when I
Now.
Oh, yeah, there you go.
nice, yeah, and then, but,
And you can change the frequency.
jumper right here.
Nice. Nice.
But it's the same idea. It's just.
It is the same idea.
Yeah, I know what you mean. I think you're right. We just looked over.
Because I would see it regulated.
I think this is about,
No, I wouldn't do.
I don't know, 0 dBm or maybe plus 10
Good output.
coming out. And it goes.
Here, so there's
I left some room. I can put like a little amplifier in it.
a lot of torque for the.
How are you using it at the present time?
I'm not.
No problem.
I'm looking forward to that.
I'm right in the middle of it. What I have to do is, I've got this board, and it has all these little push buttons on it. The way he's got it set up, it's sort of hard to use. So I'm going to just take all the switches off and put it on the front panel. This is good for like a VFO for
You know,
boot
with the,
anchors.
That's what I was wondering. That's why I asked you if you were had my mind something like that.
Yeah, well, it'd be good. And what I want to use it for is like, sometimes something will crap out, and this would be like a nice signal generator. You can plug it in and, use it for a known signal.
And then there's separate tracks.
Good.
In fact, you can gang a couple of steppers and make an antenna to or whatever.
But this goes up to a little over 30.
You got on there now, Dave.
That's 1 megahertz.
That's good. Nice.
Well, it's really 1 megahertz.
Well,
It's
it's
.000.
well, yeah, but it's not calibrated. If you put it on the counter, it might be a little off.
That's a
But there's
beautiful job
calibration
on that.
routine. What's that?
That's a beautiful job on that.
Okay, now this is a stepper motor?
Yeah, this is a little stepper motor, and it connects on to the Arduino board, but it's a powerful motor, and you can't. It
gearbox,
draws
right?
more power than this thing is capable of putting out.
So you can't run it off the USB.
No, so I have to use, I use a separate
Power supply,
to
yep.
power it.
Even with no load, you can't run it off the USB. Oh,
Oh, no,
It's
because
temporary,
this,
you can't run it off an EC. It takes pulses of
well, I know that, but if the motor is unloaded,
Probably it would if it was unloaded.
Try
It's got a
turning that.
gearbox, it's got a gearbox, so.
try turning that.
it is going to get.
That is a powerful motor, and that'll be able to turn a,
capacitor on a loop.
oh yeah,
Yeah.
big capacitor.
What I
But
was
with-
thinking of
with
is
wires
making
this
an
thick,
antenna tuner.
We're talking
So you
about
have
maybe
your coil and your cap, turning some
300 or 400 mils
You get
max.
two of these and they're running.
But still, a USB port is not geared for much.
240 mils.
240, okay, thank
Yeah.
you. So 300 or 400 was close, but I was off a little bit, yeah.
Yeah, and I don't want to draw that from there.
Well, the wires inside there are thinner than these wires, so you're going to burn that out, not this. But while it's trying to draw the current,
Well,
or it'll
well,
current limit because it's resistor.
the thing is, this draws current also.
Right.
So, and LEDs are going,
Also,
and
it's a
this,
possibility.
Oh, yeah, that's
and this driver that drives the motor,
Yep.
it all takes current, and there's not enough current in there to draw the motor.
Exactly.
Maybe there is, but
That one was my first start.
this thing draws 240 mil.
This has got a different USB chip. I think that one's a FTDI chip and that one's not.
Hold these beside each other.
This is the only difference is the USB.
Great, thank you.
I can pull out.
That's all right. So
Notice-
these are both cloned, or
No,
very similar?
This is original.
Yep.
This is a clone. But
Yep.
these guys used an FTDI USB chip, and these guys use an Atmel chip
Gotcha, gotcha.
to do the USB. But that's the only difference.
Gotcha.
Okay,
Thank you, Tom.
all right. I'll probably have more magazines for you.
Uh,